solution architect at Redis. And today I am going to discuss about the two main important keywords, which is very important for all the digital businesses or the businesses which has a digital presence. That is the scalability and a performance. So let's first understand why these two keywords are very important. That's because all the industries are now going through a great digital transformation journey. And the reason behind that are various factors. So factors like top line declining in their growth. So they are losing the businesses. Why they are losing the businesses? That again has a various challenges. Because your customer base is totally moved. So if you see a 10 or 15 years before, who were your customers? And today's customers, all the customers majorly which you have today, around 60 to 70% of the customers are a Gen Z who have born after the year 2000, right? And they have very low patience. So they need everything just on a click of a button or on within a few milliseconds or a seconds kind of a thing. So if your application is not that much capable, where if they click on a button and you don't provide them a required output within a few seconds, right? They will simply switch to some other competitor of your businesses, because now loyalty is not that much linked with each and every individual. Everyone wants the output. And in order to provide the output, they are easily ready to change the competitions and the market players as well. Not only that, the other factor which is also leading to the digital transformation is the industry disruptions. So events like demonetization, it has led to a really huge scale and performance improvement for the digital payments for the banks and the PSPs. Because now if you see, most of the people have started using the UPI in order to transfer the money as well as to take the money. So if you see a normal vegetable shopkeeper, right, he will also provide you a QR code to just to take a payment of 5 rupees, 10 rupees and so on. So that's how the business is scaling. And there are other businesses like which runs only on the online model. If we say example of e-commerce websites, live media streamings, stock broking apps and so on. So if their online presence is even down for a certain amount of time, their business is impacted. And customer will simply move to some other vendor because loyalty is not that much important nowadays. So these are some of the factors which is leading to the digital transformation of the journey across all the industries. But let's discuss the challenges which industries are facing as of now while they are doing the digital transformation. So there are various challenges which are linked to the applications over there, because businesses are older in the market, maybe 10 plus years, 15 plus years and so on. And at that point in time, we were not having lots of technologies which generally provides you faster data, faster availability and so on. So businesses have started taking call from moving from monolithic based architecture to microservice based architecture. They are moving on a Kubernetes based infra as well, so that their services are going down. A microservice will generally start in another pod and they will have a minimum downtime and so on. So likewise, you are actually safeguarding your application to provide a high availability. But what about the underlying database? Because application performs its logic, it provides a data to the UI and other stuffs, but all the data which you have, that resets into the database only. And traditional databases have a real problem when you want to work with faster reads, faster writes. Not only that, the complex operations and performance which you do on top of that, and the schema which they have, like a normal form, a primary key, foreign key, joins and other stuffs. So those things are now also becoming a challenges because those databases cannot scale generally. And especially the horizontal scale with the relational database are a big challenge. So those kind of challenges are businesses seeing as of that. And that's how there are various patterns which is coming into a market, like CQRS pattern, query a cache pattern and so on. Where you write data into a database, you also write the data into some kind of a caching mechanism and you read it from there so that your application can provide a data to the end user. But again, it has challenges like your cache is not always refreshed or not always updated. You may have a stale data into your cache which can again impact to the customer because he will provide the wrong data to the customer, whereas the relational DB has some other data. So Redis now provides something which is called as a Redis data integration in order to solve such kind of a problem, so that you do not have a stale data into your cache. Your data in the cache will always be updated and the latest one. And we will definitely discuss how we generally do that. Okay, and I will also give a demo on that part as well. So today, in order to give a demo on this feature, what I will do is that I will create a simple security app, a trading application of the stock market related stuff, where we will provide the ticks data for each and every second for the multiple stocks. And we will also load the portfolio data of the customers. So portfolio data is again a big challenge because customer base, especially in this kind of industry, is very huge, and the number of transactions which they do are also very high. So let's say if someone buys a particular stock A on a day-to-day basis for last 15 years and he has generated 1,000 quantity of a stock, it's not guaranteed that this person has purchased 1,000 stocks in a single transaction itself. They might have done a multiple transaction in the past in order to create the stock and total net worth over there. And running a top queries to give the exact count of stock which they have as on date, what's the current valuation of it on a relational DB again becomes a problem. That's why another functions which comes into the picture, which is the generalization and specialization of the portfolio, where you provide only the cumulated data and you keep the detailed data into a relational DB kind of thing. And here also the next challenge is that whenever a person buys a new stock, you again have to update data at both the end. So if you update data in the generalized form and you forget to update in the specialized form, or due to some reason the specialized data or accumulated data updation fails, customer will start putting queries and making complaints on the Twitter, which will again impact to your business, right? So how we'll do this? Because present state which they have, that is majorly based on the relational databases and other NoSQL databases. But again, those are not quick, fast in order to provide a sub-millisecond kind of a responses. Again, we are not saying that the current technologies are not good, but those are not capable of handling the requirement of the current business and current market, okay? So challenges which you generally face with the current industries are this one. So scalability and the high availability. The main thing is the sub-millisecond latency or a sub-millisecond response or a quick and faster response from those databases. Then active mechanism. So nowadays everyone knows, right? We generally see a news on for stock trading or stock trading apps, generally mostly within a month or so, on the TV channels as well as on a Twitter, that so and so company's application was down, people are not able to make trade, and people are making losses. And that's how they are also changing the providers. So again, active mechanism, where you can actually host two databases or DCDR together, and all the data write which happens on the DC, it will be replicated into DR in a async time frame, within a very short time frame, so that whenever a system goes down at one side, you can directly replicate it, load an application request to the other side, so that downtime is eliminated. So those kind of features are not there in the current market, and current traditional databases are not supporting it. So those are the challenges which industry is facing. And with Redis, we will try to eliminate all of those problems. So we will give a consistent performance of sub-millisecond latency so that your users will not have any kind of a issue in terms of a performance. Whenever there is a scale, because events like election, budget, all the digital businesses will see a huge scale, right? So you can simply do a scale up on your application side by using more worker nodes in the Kubernetes, but your database also needs the scale, right? So you can also do a scaling for a certain amount of time for the given event. Once the event is done, you do a scale down, that too with zero downtime. So that kind of a facility is also missing in current industry products. So that also we are resolving over here. And other capabilities, like we provide a multi-modeling capabilities. So the data which you are storing at a one place for a particular use case can also be used for multiple use cases, because there is nothing which is linked to the schema. So when schema and normalization comes into the picture, that's where you started getting challenges, because you have to join the tables, you have to create the views, dedicated accesses and so on. And that's how the slowness also comes into the picture. So we will solve that part as well. So let's understand a simple model. So I'm not making this application very complex. So for a trading app, let's assume this is the general form of the normal relational DB, where users are having investor data, which is the personal information of the user who is opening the account, their account related information for application as well as the bank from where they are loading the money and withdrawing the money. Then all the stock master data and security load, like which will host the data of each and every stock which users is buying on so and so date and so time. So it's a generalized data. We will not do any kind of a specialization or accumulation on top of that. So let's say if you're buying a stock, RDB bank, 10 stocks in a 10 different days, we'll store those 10 entries as it is over there, which you have in your relational DB. And we will convert your source normalized data into a denormalized form in the Redis with the help of a JSON. And this transformation we will do with the help of a RDI, which is a Redis data integration tool. Then another challenge which businesses are facing in order to moving from a traditional database to recent databases is that they have to put a lot of work in order to convert the data into a proper required format. And that's where they put a lots of effort and energy, because they have to again obviously update their application by using the application development team. But database becomes a very important part, because you cannot affect or you cannot approve even a single data loss or missing element inside any of the particular column or a field value kind of thing. And that's where the challenges also comes, because transformation is not that simple. And that's what we will resolve with the help of automation in our RDI part. So today in the application, what we will use is that we will use the RDI, which is Redis data integration. I will discuss this very shortly in detail along with the architecture, like how a relational database will convert to the non-relational database, that too automatically without any coding and without any transformation manually. The other stuff which we are using for the stock trading applications are this one. We will use the Redis streams in order to stream the data across internal microservices for various purposes. We will use JSON plus search combination for the stock data as well as for the portfolio data, so that all the portfolio data which we are converting from a relational database table structures to the JSON structures, we will keep the data as it is. We will not perform any kind of a specialization or accumulation on top of that. It will be a raw native data records of stock purchase data. I will integrate search on top of that, and then we will perform aggregation. And I will demonstrate like how fast it happens and why you can actually try to eliminate the accumulation or night job or batch job kind of thing to update those data records. And we will use a time series data structure which will host the real-time stock trading data. So I already downloaded the few stock data from the exchange's website, and I will stream those records as a 1 by 1 per second data update kind of thing. So which will be streamed through the time series my data structure. On top of that also we will perform the aggregation to identify real-time high and real-time low of that particular stock, current price, and to generate the trend chart. So these all things we will do, but let's first understand why RDI and what RDI can do. Okay. So now everyone knows, right, in order to make your application faster, you need to make a database fast. And in order to make a database fast, traditional DB cannot do that, and you have to maintain a multiple different technologies of a database. So RDI can play a crucial role over here. You can use RDI, which will connect to your relational database at one end and Redis as another end. You can select the tables which you would like to convert from RDBMS form to non-SQL based form, and it will start converting the records, and it will start using the CDC part over there, so that your application can always read data from Redis and not from a multiple copies of other databases. And not only that, it also works vice versa, because slow reading is again one part of a relational DB because of the joins and other stuff. Similarly, writing a data into relational DB is also a problem, because it's not guaranteed that your 90% of use case will write data into a single table. You will have again normalization over there, then the complexities of a primary key, foreign key, unique key of a data. Those kind of challenges are always still there, right? So you can also rely on Redis as a primary DB, where you will write data into Redis, and Redis will take care of replicating those data records into your relational databases by taking care of converting denormalized record to a normalized record, taking care of your primary key, foreign key relationships, and unique key relationship which you have on the destination part. So both of these features can be done with the help of Redis and the RDI feature which we have. So this is how the ingest part which works. So you can have one or more than one source databases for your target Redis database. And nowadays, as most of the businesses have both SQL and NoSQL databases, so you can connect both databases with the RDI. It will pull data from both the systems. It will convert the data into appropriate native data structure in the Redis. You can take a call which data structure you want, like set, hash, JSON, and so on. So we support all those data structures which are there into Redis. You can convert those data, and data will be stored into Redis. So how this works? So whenever you enable the RDI, right? So at the first part, it will take a complete DB snapshot, and it will convert the data and load the data into the database. After that, it will start a CDC, a change data capture live stream. So whenever data is inserted, updated, or deleted into your source database, the event will be triggered to the Redis, and Redis will also have those updates into the Redis databases. And not only that, while doing this kind of a transformation, you can actually add multiple calculated columns as well. So in your source database, let's say you are having 10 columns, but you want some computations to be there readily available for your application. By transferring data itself, you can do that. And you can also add some filtering conditions as well. Let's say your particular business use case is updating data into, let's say, Oracle, You don't want to copy that data from Oracle to Redis till the time it reaches to a state Z. So when state A, B, C, D, all the states are performed, and when it reaches a state Z, then only the data will be moved to the Redis. Till the time your data will be there into Oracle itself. So those kind of a filtering conditions you can also add in this kind of mechanism. And all these features which I just said, right, it requires no coding. Everything is based on the configuration, and I will show that configuration files as well, like how we will do this today. And not only that, you can also take a multiple tables. You can do a denormalization of your normal table data into a JSON based table. On top of that, you can create indexes, and your application can directly start querying that database for the business use cases, not only just to provide the cache data. So based on the use case, you can actually design this approach, and you can start using Redis in order to provide a faster data to your end customer and your business processes. Now let's see how a vice versa approach works. So again, when your application writes data into Redis, Redis takes care of writing that data back to a relational DB or a non-relational DB. And you can also have multiple copies of target databases as well. So let's say if you want a data to be updated into Oracle as well as some other NoSQL DB, this feature can take care of it. So your application just have to write data into Redis. Redis will replicate that data at both the end. And in some cases, let's say event of OTP authentication and validation and generation. If you are using OTP or 2FA kind of a mechanism, you can use Redis to generate the OTP. OTP will be stored into Redis. Whenever customer types the OTP and that OTP is authenticated successfully, your application will update the data into Redis. Once it's successful, you can simply clone that data into any of a relational DB or non-relational DB for the logging purpose, and you can remove that data from Redis. So this is how also Redis also is being used as a transaction DB for certain use cases, because it will provide you faster data and you don't need to replicate data into multiple systems and log the data over there. And while doing these operations, like writing data from Redis to other databases, again you can do the same thing. You can add a filtering condition, like whenever it reaches to a particular state, that only data will be returned to the target databases. And you can also add calculated columns on top of that. So let's say in Redis, you are having only 10 field values, but while replicating into a database, you are transferring those data into 5 different tables, a single record. So you can add other values or other columns dynamically while transferring the data. And again, this is purely based on the configuration. No coding is required for this feature as well. So that's how RDI is actually helping. It's already a live feature, so it's already helping our other customers. They have already started using it. So you can definitely try to find the use case where you can actually speed up your data, because main challenge which business faces is converting the data from relational DB to a proper structure which can be used by the application. Application level changes can be done quickly because you just have to update the queries over there. Once data is there with the application, it will continue doing the business processes like that. So that's how you can try to implement it. And these are the sources which we support as on today. Again, we are adding more sources over there. But mostly all the relational DB and important NoSQL databases which are there in market and majorly used by majority of the customers, we are already supporting that. So now let's see the architecture of a stock trading app, which I will be demonstrating now. So as I said, I have a portfolio data and account data of a customer into my relational database. I will use RDI to replicate the data from a relational DB to JSON. On top of which I will create indexes so that those data can be queried fast and we can perform the aggregations on top of that. Then I have this pricing data of our stock tick data in the form of CSV. I have written an application which streams data from this CSV to Redis streams. And from Redis streams, that data will be fetched by my deaggregator module, which is again a microservice-based service, which will read all the stock data, and it will convert that stream data into a time series based data structure, and it will store data in the time series, and my application will use that data structure. So first I will demonstrate this piece where my Redis will be purely empty. We will load the data and then I will start that services, and we'll see what great performance we are getting with that. So first I will show you that, so this is my Redis database, and you can see that there are 0 keys as on date. So I don't have any data into my Redis as of now. What I will do is that now I will demonstrate the data which I have in my relational DB. So this is the format of investors data, and there's the format of account record, and there's the record of total number of security purchases. And this is how the securities are defined, like who bought which stock at what time frame, at what price, and how many number of quantities, and what was the type of that stock, whether equity, derivatives, and so on. So this is the data in my relational database, and as you can see, I don't have anything in Redis as of now. So now I will start my service of the RDI. I will demonstrate it from scratch. I will configure it, I will deploy it, so that you guys also understand how easy it is to use. So that's my configuration file, where you just have to define the target database, which will be Redis in this case, my host number and my port number, and what type of a data structure I want at the destination. So in this case, I'm using JSON for insert as well as for the merge. And this is how the configuration file looks like. So it connects to the source database, which is Postgres in my case. This is the schema, this is the table which I have. I will use the write operation. I will give the data structure as the JSON, and I will define the key. Again, key definition can be according to the application's requirement. So I am giving some value as a predefined pretext in the hard-coded native form, and then the dynamic value of that particular row, which will be updated. And if I show you some complex operations which we are also doing over here. So while transforming the data for the security lot, what I am doing is that I am just renaming the main column. So this V, which is there in a lowercase, in Redis we will have that V into uppercase. So this kind of a renaming column can also be done along with the filtering and adding the calculated data. And here I am, while creating the key, I am making this as a dynamic key with two different identifiers. One is the account number, which will be fetched from the row record of the table, and other is the ID of that particular stock that will be again fetched from that particular row record. So now I will simply go and deploy this feature. So within 30-40 seconds, the plugin will be enabled onto your target destination database, that Redis DI or RDI that needs to be integrated and activated on the table. So as you can see, it's activated. So configurations are done. Now I will deploy the jobs which I have just demonstrated to you. So you can see our 3 jobs are already deployed over there, which we have required for the current use cases. Now, in order to sync the data from a relational DB, I will start my DBGEM, which acts as the continuous CDC mechanism or continuous data transfer stream. So now DBGEM will get started. It will take the initial dump of my Postgres database. It will load that records into Redis, and then as a part of a CDC, it will keep communicating or transferring the data to the Redis. So as you can see that these 100 records are already done. Again, 100 record of accounts are already done, and other records are getting inserted. So when I do refresh, you will see the new data like 26 key, 554K records, and so on. So data will keep increasing, but let's see how this data looks over here. So as you can see, the account data, the data format which we had in the table format, we are converted that into the native format of the Redis JSON. Then we are having the investor data, which is again converted over here properly, and the security data. So as you can see, we had defined the 2 keys. One is the account ID and then the stock ID. So both these keys are dynamically created over here as well. And the lot value V is in the uppercase, the transformation which we have applied while loading this information. So this is how the data will keep updating over here, and within few minutes we will have all the records in this system. Now I will go ahead and start my application. So it will start all the microservices and deploy it in the Docker form. And yeah, it started. So as we can see that on a real-time basis, stock ticker data is getting transmitted from Redis streams to the Redis JSON for each and every stock. For screen refresh time, I will put a delay of 3 seconds so that you can see the data changes. And you will also see the data update at these minimum and maximum values as and when the stock price is getting updated. So this data is getting stored in the form of the time series, and on top of time series, you can do a sampling, you can do aggregation, with the help of which we are calculating the min, max and the current price on the real time, and that is being demonstrated on the top. At the same time series object of that particular stock is being used to generate the real time chart. And this is how people are already using it, and you can also start using it for various use cases, our various data structure in combination with the other use cases. Now let's see the portfolio data that we have loaded. So again here I have loaded the data in the form of JSON, and on top of that I applied the search for account number as well as for a stock. So for initially what I will do is I will just type R and do a search because it's a full text search. So it is showing me data for RDB Motors, RDB Food, all the stocks which I have. I can limit the data for certain events as well. So it will now give me data only for the RDB Motors. I can also search a data in combination with a particular account and particular stock. So at what date this particular user has bought a stock of this particular event. So this full generalized data is displayed in front of him. And not only that, for this same customer, we are also showing the cumulated data, which generally you want to see on day to day in your life, like how is a portfolio moving, whether you are in profit or loss. So you can directly get total number of a stock you have as on date, and what are the current price of that stock and what is the current valuation of your portfolio. So again, this accumulation and these calculations are done on runtime. So if I buy 5 stocks now, it will get updated in the real time, because we are not doing accumulation or a specialization on top of the real portfolio data. So it's the same data which is being used as in native format. On top of that, my search is working, which is giving me the aggregation quickly. And not only that, you can see some paginations over here as well. So if I go to any page, you will directly see the data. So there will not be any kind of a delay over there. You can see the data is getting refreshed. So that's the performance you get with Redis. So when you use the various data structures in combination to achieve a particular use case or particular goal target. So that's what on the demo part. The other thing which I said, right, like the events, when something goes down, people start giving queries on Twitter, and it quickly comes on the news channel, especially on the business news channels as well, right? So this is not only for the current thing, you can apply the mechanism in a combination over here. So we can consider the scenarios of a DCDR as well. So if you are applying all these mechanism, the current product which we have done, right, you can see the mechanism is deployed on the current side. You can consider this is a production side and other one as the DR side. If you use Redis in the active format, right, all the data write, edit, update, delete, whatever thing is happening on my production side, it is getting replicated to my DR side as well. And this is also happening too fast. The main thing which comes as a concern is the network latency between two sides, and on top of that, few milliseconds which we take to replicate the data. So that's how it works. So in case your Redis goes down, you can simply put your application point to the other database where you already have the data, and your application will be up and running, and you will not face crowd with lots of noise. Or if your full site goes down due to some reason, again you have full data over here. Obviously your applications will be there into DR side as well. You can do a global switch over from a production to DR, and your user will start using the application directly, because your data is already replicated over there. You don't have to take a backup from the disk file and then move the backup files into other server and then load the data over there. So that's how the performance you get by using various components of Redis together in order to achieve a particular use cases. So thank you everyone.